All right, hey, West Springfield chemistry kids. This video is for the students who are taking the chemistry SOL. And so this video, and it might be multiple parts, but what I want to go over is the basics of the chemistry SOL, and all of the review material that you have available to you, and different things that you want to know about the chemistry SOL going in, and what are some different things that you can do to set yourself up to do the best that you can on test day. Okay. So, um, in your Schoology course, your teacher, your chemistry teacher, will assign you this folder here, Chemistry SOL Prep, uh, school year 25-26. Okay. It'll be assigned to you and anyone else who's in your chemistry class that is taking the SOL. Okay. When you go into the folder will look like this. There's a lot of material in here that a lot of it's just kind of optional extra practice that you can do. But other things are things that if you do them, you're going to set yourself up to do really well on the SOL. And remember, you have an opportunity that the majority of the chemistry students don't have. The better you do on the SOL, the more you might want to opt out of your final exam, right? Your SOL score, if you pass, can translate to a final exam score. And the better you do, the better that final exam score is going to be for you. And if you do well enough that you like that final exam grade, that means you don't have to take the chemistry final exam, which the majority of chemistry students are going to have to take because they don't get the opportunity to take the SOL. Okay. So the main thing I want to do in this video is just go through some of the things in the folder and then really take a look at what the SOL is going to look like. So you've done multiple Schoology assessments, worksheets, different lab activities, warm-ups, exit tickets, whatever your teacher assigns, practice worksheets, Schoology assessments that are multiple choice, Schoology assessments that have different types of things, free response, all that good stuff. And understand what we're testing in those assessments is your chemistry knowledge. And one way to make sure you're ready for the SOL is to know what the SOL test is going to look like. How do those questions look like? Okay, so a lot of them might look familiar to you because we use old SOL questions a lot of times on our assessments and that kind of thing. But some of them might look a little new, and you're going to be taking the test in this program called TestNav, which you can see what that looks like on your own. Okay, I'm going to show you on this video what the SOL test is going to look like, how it will be presented to you. But you can do this on your own. You can go to this website here and check it out on your own, on your laptop, see how it's going to look when you take the test on your school laptop and that kind of thing. Okay. So I would say the first three things are essential. You need to do these three top things. Okay. See what the SOL looks like yourself on your laptop. Watch the videos. Watch the introductory videos. There's plenty of more videos you can watch, but you should at least watch this video, and you should watch the previous introductory videos for the old SOL tests, because chemistry hasn't changed that much. And so what used to be on the chemistry SOL last year is going to be pretty much the same kind of stuff that's on the chemistry SOL this year. There's a few changes, but chemistry is chemistry. And so if it was on the SOL in 2015, it could be on the SOL in 2026. Okay. So definitely watch the videos in this folder, right? So make sure you're watching the introductory video, and make sure you watch, these part one, part two, part three, just me going through the different test nav practice items that are available to you. Because if you understand how to do those questions, you'll be good to pass the SOL. And the the more practice you do, the more likely you will pass advanced or maybe get a perfect score on the SOL. And that could score you 100% for your final exam grade, the better you do. Okay. And there's some other videos in here as well to watch and other things that we'll talk about as we begin our review process for the chemistry SOL. Okay. Let's go back to the main folder. Okay. So your main practice should be these FCPS assessments. So we took, if you remember back in November, December timeframe, we took the, FCPS Chemistry Unit 1 summative test. And they have 4 of those things. So the way Fairfax County organizes their unit tests is basically quarters, right? So basically, this would be the test after quarter 1. This is the test after quarter 2. This is the test after quarter 3. And this is at the end of the year, right? But if you understand the content in each of these assessments, you're going to be in really good shape. And the way you should tackle it is the way I have it set it up. If you click the FCPS Unit 1 folder, I have Unit 1 practice, and then I have the actual Unit 1 assessment. So what you should do for this is when we start on April 17th, you should do the Unit 1. The next week, you should do the Unit 2 folder. The next week, you should do Unit 3. And then the week leading up to the SOL, you should do the Unit 4. Okay? And what you should do is you should take kind of this practice assessment, just do it on your own, try your best. Once you submit, you'll be able to see what the answers are. If you need help, you should watch this video. This is me going over the answers to those questions, and hopefully you understand those explanations. And then once you do, give this assessment a try and see how you do, and see how much you've improved from the practice. After you watch the review video, how do you do on the actual assessment that is released by the Fairfax County? And I think these are going to be the main practice assessments to do. Make sure you do all 4 of them, units 1 through 4, to get used to the way the SOL is going to look like now. This is the chemistry SOL is changing for the first time in a long time. And it's the first time this year. Now, content-wise, it's going to be very similar, but there's a little bit of extra stuff, a little bit more things that they're going to ask that they used to not ask about. And it's stuff that we will cover in chemistry, and hopefully we'll cover it by May 20th when you take the SOL, but we might not. So because you're taking the SOL, you need to make sure you review at least that content before May 20th. And if you go through these FCPS unit assessments, 1 through 4, you will be exposed to all the SOL material that you could be asked about on the chemistry SOL. Okay, so that's why I think these are probably the most important. Now, if we go back to the folder, this is extra practice. You should do this as we get closer to the SOL. And this is even more SOL chemistry practice. These 2 things would be the next things to do after, along with the FCPS chemistry. But, these are going to be optional. It's really, what do you want to get out of this? Now, there's other practice assessments here. You don't have to worry about what reporting category is, but basically you have to do well in each reporting category, and these are the 5 reporting categories for chemistry. And these will give you, this assessment will be reporting category 1. So anything here is reporting category 1, reporting category. So this is just extra practice. Feel free to do these, not do them. Maybe just hit submit and see what the right answers are, and just look through each question and be like, yeah, I know how to do that. Maybe I don't know how to do that. Maybe go ask your chemistry teacher or go ask Mr. Fox some question about how to do a few things. But again, if you understand the problems that are in each of the reporting categories, you'll be fine on the SOL. And then I also have a bunch of other practice SOLs. They're paper pencil form. So you have the practice SOLs here. And then so you can print them out yourself, or you can just look at them, and then here are the same practice SOLs, but these are the answer keys to them. So if you want to check yourself, you can do that. So there's a lot of practice. You don't have to do all of it, but you want to be, prepared to take the SOL. Okay. And so the first thing to do is go to this website and see what the SOL looks like. Okay. And while we're doing that, a major thing I need you to understand about the chemistry SOL is you will get a periodic table. It will only be online, so you're going to have to constantly reference it on your computer screen, right? So you might have the question pulled up, and then you're going to have to pull up the paper period, or not, or the electronic periodic table, check it out. You'll get scrap paper, and we'll tell you what we want you to do with that scrap paper before you start the test. But you'll be able to write stuff down, but you don't get a handheld periodic table like you do when you're taking a test in chemistry class. Okay. And you get to use Desmos as your calculator. So hopefully you're good with that. And so you do get a calculator, you do get a periodic table with all the information you're used to, but you don't get a formula sheet. So whenever you're taking a test in chemistry, if you're using the back of the periodic table and all those different formulas and all those different pieces of information we give you, you don't get that on the SOL. Okay. So you're really going to want to do the memory dump technique before you start the test. You want to make your own cheat sheet, your own formula sheet, one by memory. You want to memorize it the morning of, the night before the chemistry SOL. And before you read question 1, you want to recreate that formula sheet, that cheat sheet on your scrap piece of paper. Once your test, proctor gives you your scrap sheet of paper, memory dump, right? If you run out of room, ask for another scrap sheet of paper, and ask for another one, and ask for another one. Okay. Do the memory dump, take 10 to 15 minutes, write out all the equations that you need to know for chemistry that you've memorized and that you're ready to go, and then start reading the question. If you do that, you're going to be in great shape. If you don't do that, you're going to make some simple mistakes that you wouldn't have made if you reminded yourself that molarity was moles over liters and not moles over milliliters or grams over liters, right? So those are going to be important, right? And so another thing you might want to understand as you're doing any of the practice that's in here, anytime you reference a formula, you have to go double check. Is this how you calculate percent error? Is this what molarity is equal to? Is this how I convert liters to milliliters or vice versa? Anytime, is this how I calculate pH? Is this how I calculate pOH? Right? Every time you're checking and you're checking the back of your periodic table, your formula sheet, to double check yourself, write it down on your own scrap sheet of paper and make sure you have that memorized so you can recreate a formula sheet before you start the test. Okay? All right. So if we go to this website, this is what will pop up. Okay? You'll have to click on science. Okay? And then you'll have to click on chemistry. Okay? Now, what I want you to understand is this is the first year that the chemistry SOL is going to be based on the chemistry 2018 standards. All previous SOLs, including last year, were based off the 2010 standards. If you take the practice SOL from the 2010 standards, if you want to see what that looks like, you just click on start, agree. Okay. And notice there's 27 practice items. Okay, here. Okay. Now, if we go back, all right, and we do the 2018 test, and this is probably this is more important for you to do than this. Notice that there's only, when we start, there's only 13 practice questions. Okay. Now, 9 of these 13 practice questions are questions from the 2010 chemistry practice SOL. And it's 9 of these 13 are from the 27 practice items from the 2010 test. So this question is a practice item on the 2018 standards. It's also a practice item, the same exact question is a practice item on the 2010 chemistry practice. There's only 5 questions out of these 13 on this current chemistry SOL practice items that the Virginia Department of Education has published. Only 5 new practice items. So the 27 practice items on the 2010 version of the test are going to be questions that they will ask now, right? Again, chemistry hasn't changed a lot, right? So the underlying fundamentals of chemistry have not changed. So just because this is a new year and new standards really isn't going to really change the types of questions that they ask. Okay, so I do strongly suggest, again, I'll X out of this, that you do these practice items, okay, and then do these practice items, the 2018 practice items and the 2010. Now, if you're in YouTube or you're in the what does the SOL look like folder, the videos that are next after this video are me going over these practice items. So I'm going to go over the 13 practice items in the 2018 right now in this video, but the next videos go over the 27 practice items that are in this one. And I would say, again, 9 of the 13 practice items from this practice chemistry SOL are part of the 27 practice items in this one. All right, there's only 5 new practice items. Okay, so again, you get the Desmos calculator, so you can use that. Okay, but remember, there is no formula sheet. There is no back of the periodic table that has a reminder of how to calculate percent yield or percent error or the steps for stoichiometry or different shapes of molecules or polyatomic ions, names and charges. Okay, so you really need to make your own cheat sheet, memorize it, memory dump before you start the test. Okay, so let's go and check it out. Okay, so the first thing I want us to do before we start answering chemistry questions is, where do you find the periodic table, right? You got your calculator that you can use. Okay, you can write, you can use a ruler if you need to measure. I haven't really ever seen a question where you actually have to use the ruler to measure on a chemistry SOL. That could be a thing. They give it to you. You can X out answer choices if it's multiple choice and all that good stuff. Okay. But where do you find the periodic table? You have to click this. It'll say exhibits here. You click it, and that's what you get. That's the periodic table you get. You can make it bigger, I think, if you want to. Okay. All right. Now, you might be worried because if you look at the boxes, it has the chemical symbol, but it doesn't have the chemical name. What you should notice is when you look at a question, anytime they mention an element, like here, sulfur, look, they put the chemical symbol in parentheses here. So, right, sulfur's an easy one, but if they said silver and you forgot silver was Ag, they would have silver and they would have Ag in parentheses. And that means you go to your periodic table and you would find Ag and all the information pops up, okay, in this box. So if I want to go to sulfur, right, it's telling me its atomic number is 16, its atomic mass is 32.06, its chemical name is sulfur, chemical symbol is S, right? So you get all your information. You get that bold staircase telling you, hey, we got metal elements this way and we got non-metal elements this way, right? So we got the transition elements, right? Lanthanide and actinide series and all that good stuff, okay? But just kind of understand that you might have to do some hunting. You're not going to need to reference the periodic table for every question, but remember you have it, right? And a lot of students forget that they have it and they get questions wrong that are just easy. Hey, I just look it up on the periodic table type of question, okay? So make sure you understand how the periodic table works, play around with it, make it bigger, make it smaller, whatever works for you. And understand you're going to have to check it out, get scrap paper. So if you need to write down information, then you can write it down and then you can check back in the question. Okay. All right, so now let's get into some chemistry, right? All right, so they say atoms of sulfur, okay, um, 16 protons, atom 1, 16 protons, atom 2, 16 protons, atom 3, 16 protons, atom 4, 16 protons. So that should be saying, oh, yeah, remember, if they're the same element, they have the same number of protons, the same atomic number. But notice we have different number of neutrons and we have the same number of electrons. So what does that mean? They're atoms, not ions. So we're talking about things that are neutral. So protons and electrons are the same. So what's the difference? They have different masses. How do they have different masses? Because they have different number of neutrons. And remember, mass number is protons plus neutrons, right? So basically, this is an isotope question. It's really just what's the definition of an isotope? And let's see. So it's not about polymers. So like, we could X that out. It's not about ions because they're all neutral there. And we know they would have different mass numbers, so we could cancel that out. So obviously it's got to be choice A. Different isotopes of sulfur have different number of neutrons. And again, I have kind of my notes here, right? Atoms, not ions. We're not talking about polymers. It's an organic chemistry thing. Ions, they would have to have a different number of electrons, right? Compared to the protons. And we know that mass number is protons plus neutrons. So if they have different number of neutrons, they would have a different mass because they all have the same number of protons, right? So it's just choice A there. Okay. So let's move on to the next one. Shielding effect. Okay, so it's asking which of these ions or atoms have the greatest shielding effect. And what you have to remember are periodic trends. Shielding effect increases as you go down, but it's around the same as you go across. It's really just the more energy levels you have, the more shielding there is. So as you go down the periodic table, you gain an energy level. So you have more and more energy levels, you'll get more and more electron shielding. So it's basically which of these elements is further down. If we recognize we got barium, strontium, calcium, magnesium, they're all second group metals, right? Alkaline earth metals. So here, magnesium, calcium, strontium, barium. What's the one that's furthest down? It's the barium. So barium has 6 energy levels, right? So it's going to have more shielding. So it's going to be barium. So barium would have the greatest shielding. And in this scenario, magnesium would have the least shielding of these 4 elements. Okay. What did I make notes? Yep. So increases as you go down the periodic table, right? More energy levels equals greater shielding. Okay. So again, this practice item is on the 2010 chemistry standards as well. We're not going to get a new question for the new standards until I think question 9. Okay. Or question 10 maybe. All right. So select the column in which all elements exist as diatomic molecules. So here, I could select that column, I could select that column, but notice like I click there and over here it's saying I can only select one. So I have to unclick that one. If I wanted to click this one, I'd have to unclick this one. If I wanted to click this one, we just got to remember our diatomics. Remember, you can say go to 7, make a 7 in hydrogen. You can say Brinkelhoff, right? But you could also say heck no. That would be hydrogen, nitrogen, oxygen, and then halogen. And remember the halogens. So fluorine, chlorine, bromine, iodine, those are all diatomic. So it's this group right here, right? So we just got to remember our 7 diatomics, right? If we start at number 7, which is nitrogen, and we make a 7, we go down to iodine, right? So it was this column here. Those are all diatomic. All right. Okay. So we go to the next one. All right. So here we got to click and drag. Now I can't use my elimination tool, but we just have to name this compound PbO2. And so the first thing we have to do is recognize that it's an ionic compound. It's not a covalent compound, right? So I know I'm not going to use tetra. I know I'm not going to use di. I'm not going to use tetra. I'm not going to use di. We don't use monodi, tri, tetra. Those are for covalent compounds. This is an ionic compound, right? All we have to do is name the cation, which is lead, and then we have to name the anion, which is O, oxygen, but remember we change it to oxide. So I know that the last part of the name is going to be oxide. But we have to remember about lead. is lead is one of those ions. I call them mom ions. They have multiple oxidation states, multiple oxidation metals. So it could be a 2+ ion or a 4+ ion. So remember, we need a Roman numeral. So this is either going to be lead 2 that I put here or lead 4, right? So it's either lead 2 oxide or lead 4 oxide. Now, a lot of students are going to make the mistake and think it's lead 2. But remember, oxide is a 2- ion. And based on the formula, you have 2 of them. So that's a total of 4-. So the lead has to be 4+. So this is lead 4 oxide, right? So like I crossed out these because I knew I shouldn't use the prefixes because I have an ionic compound. And then I got to remember oxygen is 2-. But since I have 2 of them, the one lead has to be 4+ to bounce the charge. So lead 4, not lead 2. Okay. So in this one, okay, again, not multiple choice. And the structure, you're going to have 55 questions, and around 80% of the questions are going to be multiple choice, just regular multiple choice questions, and 15 to 20% is going to be these types of questions. They call them technology enhanced questions, where you're like clicking and dragging or doing other things. So this one, we're just balancing the equation by adding coefficients to the boxes. But notice in the directions, each box must have a coefficient. That's telling you that if you have a 1, make sure you put 1 in the box. Technically, 1 is understood. So if you're free writing an equation and you have a thing with a 1 as a coefficient, you don't have to write the 1. But in this problem, you need to make sure if you have a coefficient of 1, you got to put a 1 in. So kind of just go back and forth. We got 1 aluminum, but I got 2 aluminum, so I'll put a 2 here. That balances the aluminum. Over here, I got 2 irons, but over here, I only got 1 iron, so I got to put a 2 here to balance the iron. So the iron and the aluminum is balanced. Now I have 3 oxygens on this side. I got 3 oxygens on this side, so everything's balanced now. So I just got to put a 1 there and a 1 there, and I'm good to go. All right. All right, let's go to the next one. All right, so in this one, they give us the molar mass of a compound, and they ask us, and they give us the empirical formula of a compound, and they ask us for the molecular formula. So I would, you could do this. There's, one way to do it, and there's, for multiple choice here, there's process of elimination way. The process of elimination can't be that because NO5 doesn't reduce back to a 1-to-2 ratio, right? It's a 1-to-5 ratio. So 2-to-4 does reduce back to 1-to-2, so that could be an answer choice. But 3-to-3 reduces to 1-to-1, so that can't be an answer choice. Now 3-to-6 also reduces back to 1 and 2, 1-to-2. So B and D could work. Now, how could I check this? What I could do is just add up the molar mass of this and see if it's close to 92. And if it's not, then add up the molar mass of this and see if it's close to 92. Right? So remember, 4 oxygens would be 64 and 2 nitrogens is 28. So 28 plus 64, 92. So it's got to be that one, right? This one would have a molar mass that's too hot, right? 2-to-4 reduces to 1-to-2, and 2 nitrogens and 4 oxygens adds up to that, right? So what did I say? Yep. Okay. Now the technical way you should do this, like let's say it was a free response question, is you should take the empirical formula that they give you and figure out its molar mass. So what I did was add up 2 oxygens, so 16 plus 16 plus 14 for nitrogen, 14.01, right? So NO2 weighs around 46 grams per mole, and the molar mass of the compound is 92. So then what you do is the molar mass of the compound divided by the molar mass of the empirical formula, so 92 divided by 46, that comes out to be 2. And all you have to do is double the empirical formula to get the molecular formula. So if this came out to be 3, we would multiply these subscripts by 3. If this came out to be 4, we would multiply by 4. It came out to be 2, so we double our subscripts and we get the correct formula. Okay? But again, multiple choice, be a smart test taker. If you can eliminate 2 questions and then you have to take a blind guess, now it's 50-50, right? we could do this without finding the molar masses. We could, do it this way. If you add up this adds up to 92.02, so close to that. This adds up to 138.03, so it can't be that, right? Okay. All right, so let's go to the next one. All right, so here we have a stoichiometry problem, right? We're given the mass of water, find the mass of ammonia, and they give us our balanced equation. So we know what our recipe is, okay? We just got to follow our steps or stoics, right? So step 1, know the recipe. So that's the balanced chemical equation in this case. Step 2, take what we're given and convert it to moles. So what was I given? 147 grams of water, so I got to convert grams of water to moles of water. Then step 3, we're going to use the recipe. According to the equation, 2 moles of ammonia will react for every 1 mole of water produced, okay? And then we got to convert to desired units. We don't want to know moles of ammonia, we want to know grams of ammonia, all right? So I have it written out here. All right, so remember, yields just means produced. So it's saying if 147 grams of water is produced, how many grams of ammonia were used, right? So we'll take 147 grams of water, we'll divide by the molar mass of water, that'll give us moles of water. Then we'll multiply by our mole ratio in our reaction. The ratio is 2 moles of ammonia, and the coefficient for water is 1. So 2 moles of ammonia for 1 mole of water. Moles of water cancel out, and we're left with moles of ammonia. And then we didn't want moles of ammonia, we wanted grams of ammonia, so I'd have to use my periodic table. If I don't know that nitrogen's 14.01 and hydrogen's 1.01, I'd have to reference my periodic table to remind myself of that, okay? And that's where we get the 17.04, right? Nitrogen's 14.01, and then 3 hydrogens would be 3.03. We add those up, we get 17.04, right? So this would be our dimensional analysis. This would be the work we need to do. Remember, you got your scrap paper, so you can do that work, okay? You're not going to have to do a lot of different side questions, problems, and that kind of thing. A lot of the stuff you can do in your head or just with your calculator and that kind of thing, but there's going to be some problems where it's going to be best if you take the time to write out the setup and write it down, okay? So when you do your math, it comes out to be around 278 grams, okay? So let's go to the next one. Oops. Okay. So we go, it was 278. We'll go to the next one. All right. So this one's asking basically what's the relationship between volume and pressure. We have to remember that pressure and volume have an inverse relationship, right? So Boyle's law, one of our gas laws, P1V1 equals P2V2. So what this should tell you is if the other things are staying held constant, the amount of gas and in terms of number of particles, moles, and temperature, right? If those are staying the same, if volume increases and the gas particle gets more spread out, they're going to collide with the counter walls less, and so pressure would decrease, right? Container walls. So, so as pressure goes up, volume should go down. So what do? The pressure was doubled. So what's going to happen to the volume? The pressure increased, the volume should decrease. So again, eliminate the increases, right? We know that if pressure goes up, volume needs to go down, right? That's an inverse relationship. But what is it going to go down by, right? So we got decreases by a factor of 2, and we have decreases by a factor of 25, right? Well, if pressure goes up by a factor of 2, volume will go down by a factor of 2. So the pressure was doubled, that's an increase by a factor of 2. So the volume would decrease by a factor of 2. Okay. And if you wanted to, you could play around with your, Boyle's law here. You could plug in 1 atmosphere and 50 milliliters for your V1. And then what would be, if the pressure doubled, if it was 1 atmosphere, now this would be 2 atmospheres over here. So what would happen to V2? It would go down to 25, right? So it would cut in half, right? All right. I think what maybe they get confused is here is the initial volume was 50, so the volume should go down to 25, and so maybe that's why they have the 25 number there. So the new volume should be 25 milliliters, which is a decrease of volume by a factor of 2. Okay. All right, let's go to the next one. All right. Here we got heat of fusion and heat of vaporization. This is where we got to be careful. They gave us these two things, but for this question, we're talking about melting and we're at the melting point. So we only need this value here, the heat of fusion. If they were asking about boiling or condensing, we would use the heat of vaporization. If they had ask about melting or freezing, we'll use the heat of fusion. Heat of fusion is the energy required to melt, right? Heat of vaporization is the energy required to boil or vaporize, right? So we got to make sure we're using the right unit. If this had said boil at the boiling point, then we would be using this value, okay? Now for this one, we just got to use a dimensional analysis. Remember, this is how much energy per mole of the substance, okay? And we want to know how many grams we can melt with this much energy. So remember, we can take a measurement like this and it can be our conversion from moles to kilojoules or kilojoules to moles. And that's what we want in this case. So we'll take our 7.8 kilojoules and what we'll do is we'll divide it by the molar heat of fusion, right? What does that do to the units? It flips the units, right? So you have kilojoules on the bottom and moles on the top. So this will cancel out kilojoules and give us moles of the compound. We'd again have to reference our periodic table if we didn't know carbon's molar mass and hydrogen's molar mass and chlorine's molar mass by heart. So we'd have to, chlorine's 35.45, you got two of them. Hydrogen's 1.01, you got two of them. And carbon's 12.01, you got one of them. That's where this number comes up. So I added up the molar mass of the compound. And once we figure out moles of the compound that we can melt, we can multiply by the molar mass to get grams of the compound we can melt. So it comes out to be 144. Okay. So C in this case, all right. All right, so what are we on? We are on, what question was that? That was question 9. So yeah, so now that this practice item here, this last one, number 9, this was the same question on the 2010 practice SOL, right? So understand 1 through 9 are all practice items that are on that previous one, right? So nothing new. This is new, okay? Now, colligative properties aren't new, right? It's stuff that we will talk about in chemistry, but I haven't seen a lot of questions about colligative properties in a long time on the chemistry SOL, so maybe they're going back to that, right? So we got 2 charts, and it's kind of annoying because you can't get this into one screen. But basically they're showing us how as we dissolve sodium chloride in solution, the freezing point of the solution decreases, right? So pure water freezes at 0, but the more salt we dissolve into it, in this case, specific salt is sodium chloride, the lower the freezing point gets. And it reaches a point where, right, at some point you can't dissolve any more salt unless you add more water, right? So there's a point of maximum concentration that the salt can get, and that's going to be the lowest freezing point reached, right? Then let's look at the other table here. And notice, it's percent, it's like the solution's concentration isn't measured in molarity, it's measured in percent by mass, percent by weight. And then if we look at the table, they give us de-icers, so different things that we could add, right? And notice they're all ionic compounds, they're all salts. Different salts that can be used for de-icers. And it tells you, which ones give you the lowest freezing point, right? So if we dissolve this one, we get a pretty low freezing point. If we dissolve this one, we get a freezing point, right? And what we should recognize is about magnesium chloride could be a salt that gives us the lowest freezing point, but magnesium chloride reaches a point of saturation a lot longer or a lot sooner than sodium acetate or potassium acetate. So more of this can dissolve in a given amount of solution. So you'll end up with more particles, even though when this dissolves, you get 3 ions, but when this dissolves, you only get 2 ions. When this dissolves, you only get 2 ions. But it's really about how much can actually dissolve in, a given amount of water, right? Right. And then enthalpy, remember, enthalpy is the same thing as heat, right? And enthalpy of solution is like the delta H of solution, the change in heat of solution. So this is telling you when you dissolve sodium chloride, it actually absorbs energy as it dissolves. But when you dissolve these salts, they're exothermic as they dissolve. So that means as they dissolve, they release energy to the surroundings, Okay. All right. So those are the tables, and let's get to the first question. So it's saying figure 1, right? And they give us the table again, or the chart. It says how many moles of NaCl are in 100 grams of a solution that reaches maximum freezing point depression? So freezing point decrease, right? So we'd have to go to our chart. The lowest freezing point is here, and it's at 23% sodium chloride by mass. Okay. And they make the numbers kind of easy for us. They say 100 grams of solution. So if 23% of the mass of the solution is sodium chloride, that means if you have 100 grams of solution, that means you would have 23 grams of sodium chloride. So basically, essentially, this question is asking how many moles is 23 grams of sodium chloride? Okay, which is not a difficult question to answer. Okay. All right. So in 100 grams of solution, based on the chart, we would have 23 grams of sodium chloride, 23% by mass of 100 grams, 23 grams of sodium chloride. And so what we have to do is take 23 grams of sodium chloride divided by the molar mass of sodium chloride. It comes out to be 0.39 when we calculate it. So 0.4 moles. Okay. And then when we look at the next thing, okay, the chart really has nothing to do with it. It's just how does a salt dissolve in water? Remember, the ions separate. So when sodium chloride is in solution, it's not sodium chloride together. It's sodium ions and chloride ions. They're separated and they're individually surrounded by water. So a couple things we can cross off. We could cross off this thing, okay? Right? You won't have NaCl together, right? When a salt dissolves, the ions separate, right? We could cross out this thing. There's no such thing as Na1 minus, and we could cross out this one thing. There's no such thing as Cl1 plus, right? So sodium and chloride, okay? And what we have to remember about water is polar, and the oxygen side is the negative side, and the hydrogen side is the positive side, right? And opposite charges attract. So the sodium should be facing oxygen because the sodium is positive and the oxygen is the negative part of water. And the chloride should be close to the hydrogens of water because the hydrogens of water are positive and the chloride is negative, right? So if we go back to the question here, I would put the sodium ion here because it's interacting with the oxygens. And I would put the chloride ion here because it's interacting with the hydrogens. All right. All right, next one. When the ice melts after sodium chloride is used, the de-icer becomes less effective. Okay. So as ice melts, what is it turning into? It's turning into water. So it's increasing the volume of the solution by adding more solvent. We're diluting the solution because as the ice melts, it's part of the solution now. And so you're adding more water to a solution, you're diluting it. Okay. So the lower the concentration, the less the freezing point gets depressed, or the less that the boiling point gets elevated, right? So it's just because it's less concentrated, right? Right? More water into the solution, water's the solvent. When you add more solvent, you're diluting your solution, right? You're making it less concentrated. Okay. And then if we go to the last question, here we go. It's asking, based on table 1, as solid sodium acetate dissolves, it requires energy, absorbs energy. Require and absorbed heat are the same thing. Adds energy to the system. That means the system, the reaction's absorbing energy. So A, B, and C are all kind of saying the same thing in terms of endothermic process. Endothermic, the reaction absorbs energy from the surrounding. Exothermic, it releases heat, it releases energy to the surroundings, right? And what does it say about sodium acetate? It's an exothermic process as it dissolves. So it's releasing energy to the surroundings, okay? So it releases heat, which speeds up the melting of the surrounding snow and ice. Okay. Right. It's not adding energy to the system, right? Exothermic is releasing energy to the surrounding. It's not absorbing energy, it's losing energy, it's releasing it. It's not requiring energy, it's producing energy, right? Requires energy is endothermic. Absorbs heat is endothermic. Adds energy to system, endothermic. Adds energy to surroundings or releases energy to surroundings, that's exothermic. Okay. All right. So again, watch the next video in the series to see the rest of the practice items, okay, from this practice test. All right. So I hope that was a good introduction to the chemistry SOL for you. Start doing the practice. The more practice you do, the better you're going to be. If you ever have a snag, you can ask your chemistry teacher. You can ask me, all right? Come flex, come stay after school, come Monday mornings, right? Whatever you need to do, send me an email in Schoology, right? Tell me what you're having a question about, and I can email you a response or something, or you can come talk to me, okay? But start reviewing, start getting ready for the SOL, and you're going to do fine. But remember, your goal is to not just do fine, but your goal is to excel. And then you don't have to worry about a chemistry final exam. Who wants to worry about that in June? I don't. I know you don't. And you're one of 31 students that have that opportunity. All the other kids in chemistry, they don't get that opportunity. Why? Because you get to take the SOL. So count it as a blessing, get yourself prepared for it, and you're going to be good to go. All right.